Alright, so today we are going to talk about a new type of algorithm. It is called clustering algorithm. And this particular algorithm, it is called kmeans. And the full name is kmeans clustering algorithm. If you are doing the statistic or you are just have some background in machine learning, then this is one of the most famous machine learning algorithm that you can find online. And the nice thing is that it is easy to implement, easy to understand, and the effect is also nice. The performance is good. So we are going to talk about this one. Alright, the idea of this algorithm is quite simple, at least the outcome. Say we have some points here. Oh, you can barely see, right? Let me draw the points a bit larger. Okay, so anyway, you got some points, and you should have known that points is the data. So we have some data in the space, and let's say we don't know anything about that. We just have a bunch of data. You can imagine that these are a bunch of photos. This is the photo of mine, photo of a dog, photo of a cat, and photo of our president, something like that. So you collect a lot of data, and you somehow want to separate them into different groups, and this group is called a cluster. So this algorithm, after the k-means algorithm, it will provide the labels of these data. Okay, so the same set of data, but there will be some label. For example, label 0 to this point, and this point, and so on. And for the other group, there will be a label to each point. Okay, so all the points with the same label is called a cluster, 一个群聚, a cluster. So the point of this k-means algorithm is you take some data, there's nothing on there, but afterward you got some labeling on the points. And the points with the same label are considered as the same category. Okay, so again, for example, if you want to say check the political standing of each newspaper, this is, say, I don't know how to say that in English, like 自由时报 and 联合报, something like that. You can do some text to vex. You can change that to a vector and try to understand what's the relation between them. And afterward, you will see, okay, this is more inclined to a certain standing, and this group is more inclined to a different standing. Or the other easiest way is say, okay, I have 100 students, and this student has a mathematics score is 100, and English score and chemistry score, and you can put it on the space. And if you somehow want to partition the students into several groups, and so that, okay, this group is maybe they are better at mathematics, and this group is good at chemistry, and this group is good at physics, something like that. And afterward, you can partition that into several groups. Okay, so that's the idea of clustering. And so in terms of the computer, we will supply the data by a matrix called X, and it has n samples and D. And again, each row is data. So a point is a row in the data. Now, as we explained here, after the k-means algorithm, it is not going to give us the new set of data. It is the same set of data, but we are going to get 0, 0, 0, 0 for each points here, and 1, 1, 1, 1 for each points here. So we are going to get the labels, and I call that as a y new. And this y new is just a one-dimensional array. It has a shape n common and nothing. Okay, and what is in this n? What is in this y new? There are labels, and particularly there are labels from 0 to k minus 1, and this k is this k. So when you run this k-means algorithm, you have to supply one parameter, which is k. So for example, if you supply k equal to 3, then it will become 3 groups. But if you supply k equal to 4, maybe it will partition this part into 2 groups, and then 0, 1, 2, and 3. So this y new contains all the labels, and the labels is between 0 to k minus 1. It tells which group you belong to. Okay, so I think that's an essential idea of this k-means algorithm. And let's talk a little bit about the terminology and the philosophy behind this algorithm. So there are some easy terminologies. For example, when we say these all belong to the same cluster, right? They are all labeled by 0. So we call these whole groups is a cluster. And cluster in this particular algorithm means that there are the points with the same label. So we have 3 clusters on the picture here, and you can decide what is the k you want to use. All right, and more than that, each cluster you can calculate one of its center. Well, not one of. I mean, each cluster you can calculate its center. So this is the center of a cluster. This is the cluster center. And cluster center means that the average of all points in the same cluster. Okay, and it is also called the means. Okay, means means average, or you can call that as the center. And so k-means means you have 1 means, 2 means, and 3 means. And you have k-means after the training of the model. Now again, once we know what are the clusters, okay, this is one cluster, and which is defined by the algorithm. This is the second cluster. This is the third cluster. And after that, we are going to find out the first mean, and the second mean, and the third mean. Okay, so you will see that each point is has one of the closest center. Okay, this point is pointing to this center. This point is pointing to its center. It belongs to this group, so the center is the center of the group. So now, for each point, let's try to find out what is the center of the group. So for this point, let's find out the center of the group, and center of the group, and center of the group. And now we can define what is the inertia. Okay, inertia is the sum of the square distance of all these blue lines. There are several lines here. We can calculate each of the distance and then take the square and then take the sum. And it is called the inertia. It is a terminology in this algorithm. So it is the distance of each point to its center. Okay, so we got most of the things defined. We're almost there, but I'm about to change the page. So before I move on, is there any questions on this page? Okay. 有要用中文问也是可以问的哈 ，or you can tell me later. So as I mentioned, the EMI course just say that I have to speak in English, and it's up to you. Okay. 总之有问题都欢迎哈。All right. But we are almost there, and once we are done, we can discuss more questions. All right. So let me give you some example. So, say we have some points. Okay, and let me copy that twice. Sorry, do that again. So for this particular data sets, it's so obvious that it looks like just two clusters. Okay, so they are the same data set. If I put the center here and I put the center here, then the inertia looks like this. However, if I'm kind of idiotic, which means stupid, and I put the center here and center here, okay? And this cut the line here and this cut the line here. And in this case, the center has longer distance to its points. So on the right hand side, this one has larger inertia. You see the line is longer, and on the left hand side, it has a smaller inertia. Because the center is just closer to the points, okay? So the goal of this algorithm is try to label each point and label that by 0 to k minus 1. Okay, and after that you are able to calculate the center, and so that the inertia is the minimum. And this algorithm will help you to find out some labeling, and so that you find out the centers, so that the inertia is relatively small. It is not going to cut the data in this way, because the data in this way, the inertia is going to be bigger. All right. With this understanding, we are able to just apply the algorithm from the package and try to see the effect. So let's learn how to run the algorithm using sklearn. It's easy. You have to import the module. Is called sklearn, and this time it is from the cluster. If you look at the source code, actually in each of the computer you will have a folder called sklearn, and the folder contains another folder called a cluster. And inside the cluster, there is a file called kmeans. But you don't have to know this. I'm just saying that what does this mean? Because sometimes you see import numpy, and sometimes you see from numpy.linear algebra import something else. And it's quite straightforward. You just go to certain folder and try to import one function. And after that, we select the model as the kmeans. As usual, we can supply some parameters. And after that, we do while and model.fit predict from x. So x is the data, and y is the label. And you will notice that this time it is a bit different. We are doing the prediction instead of the transformation. So recall, if you are doing x to x new, this step is called transform. And today we are going to do x to y new, right? We are transforming the data into the labels, and so this is prediction. It's predict. And somehow after this line, you can do something like this is a side story. After this line, you can do model dot predict. So you have doing the fit part. You have done the fit part, and you can do something like x1. You can supply a new set of data, and this new set of data, the model will give you the corresponding answer, and that's kind of following the name of the prediction, right? You are predicting what are the labels. But later on, we are going to talk about this one. Let's just keep it simple for now. All right. So with this in mind, we are able to run the algorithm. But before that, let me tell you what are the parameters and attributes that we can do. So parameters, you can run, for example, model question mark, or just one question mark. I think that should be good. You can check model question mark, then you will output the doc string. So you can tell, okay, this model will take some parameters, okay? Or let's say, let's make it easier. You can do kmeans. After you import the module, and you can do kmeans question mark and run the cell, you will see the documentation. And one of the most important thing is the number of clusters, and it is called n cluster in this algorithm. And n cluster is simply equal to k. It is the number of the clusters. And after you finish training this model, there are some attributes. Okay, after you finish that, you can use model dot something, and this something can be, for example, the cluster center. And this is an array, and this array composed of k centers, and each center is in dimension d. So each row is the center. Alright, and the next one is called label, and labels is just easy. That's the y new that is about to spit out the output of this algorithm. And the last one is the inertia. So most of the things is suggested by the name, and so inertia is the inertia, right? And so here I'm just going to give you the mathematic formula, but you should already know what it means. Xi minus the center and take the square sum. And here I will run through all points. And once you pick a particular xi, then j is the label of xi. And mu j is the center of this cluster.